Do you guys follow? Everybody understand? Did you get over there? Yeah, yeah. Otherwise, we'll hear it from YouTube. I'll tell you that right now. It won't be right away because he's still back in series at the moment, but in about a month from now, some particular fellow who's watching these videos. So he started at the start about 3 weeks ago or so, and his comments have gotten progressively more annoyed as he's gone through the course. So it's hilarious. Sorry, what's that? I do not make money on YouTube. Should I make money on YouTube? Should I monetize it? I think I could make tens of dollars doing that. Yeah, but maybe I should. Gas money? That's true. Like one person could go watch a movie with that money. But oh, and then solve for y. So what do you got? Y equals 2 minus 1/2 e to the minus 2x plus c. And I'm multiplying both sides by e to the 3x. Right? E to the 3x makes that go to 1. And so what do we have? We've got y equals to minus 1/2 e to the x, right? Plus c e to the 3x. There you go. That is the explicit general solution. Now I know this is, you guys probably haven't ever seen this before about a half hour ago, but do you think you can do it? Right. I think everybody here can do it. Do you see what I'm talking about the redundancy? You know, if we had done this wrong, when we get to this step and we try to, identify this as the derivative of a product, it wouldn't have worked. If I had somehow missed the minus, if I had missed the minus and you could say hypothetically I put e to the 3x, then I would have had dy dx e to the 3x minus 3 e to the 3xy equals to e to the x times e to the 3x, right? And the thing is, some of you might write ddx of e to the 3x times y if you're just trying to memorize this and not understand it, but that would be foolish because that's not true. This is not equal to that because if I differentiate this, I get e to the 3x dy dx plus 3 e to the 3x times y, right? Not minus. And why is that? Well, because the integrating factor is not e to the 3x, it's e to the minus 3x. So if you're paying attention to the details here, there's a nice kind of self-redundant check in here. All right, so let's spend the rest of the class talking about solution. And then we'll be out of here. So I'll probably try to start working homework problems tomorrow if they're good. If the homework problems are no good, I may tell you, forget about these homework problems. I'll have to take a look. Oh, and you can keep that paper. I know who was here. You have all earned 10 points, but I saw you writing. There's no sense in me collecting them and losing them. Sorry, John. John just tore out the paper meticulously, carefully. But you should keep But you should keep it. All right.
Homework problems from what? Is that from your website?
Well, did I not ever assign homework on this part of the course? Oh. I will have to think about that. I'm sorry, guys. That's a hole in my... It's a good thing you guys already did that course evaluation, right? So like course well organized. No, didn't assign homework in the last part of the course. Sure enough, you're right. All right, let's look at this. Let's talk about test. So I posted this in course content and also a blank copy of it for you. So a lot of you missed problems 1 and 2, and I think those of you who missed it probably won't miss it if I ask it again. Is that fair to say? Yeah. Because these are not that bad, right? It's just you were not, I think, expecting this question perhaps, right? Maybe that's fair. Any questions about number 1? So that's the polar coordinate formula. All I did was put in what r was given to be, 8, and cosine of pi over 3 is a half, sine of pi over 3 is root 3 over 2. So that gives me this and that. Now, if you had that correct, but the decimal version of that, I still give you credit. It's not like, that's not what it's about. If you got it wrong, it's more wrong than that. It's not an exact value thing. Anyway, so this one here, I always ask questions, almost always, about quadrants 2 and 3 because I want to see if you're really thinking through it. And some of you were. A few of you got this right, not too many. The point here is we're in quadrant 2 where we have x negative and y positive, so the inverse tangent will not tell you the right answer. It'll steer you over here if you take inverse tangent of like minus 1 over root 3. Anyway, if you look at this, this is a 30-degree angle, and so, or pi over 6. So if this is all pi, then pi minus pi over 6 gives me the standard angle, which is 5 pi over 6. And the radius, on the other hand, is the square root of x squared plus y squared, which in this case is 3 plus 1, which is 4. Square root of 4, of course, is 2. And there you go. Any questions? No? All right. I think those of you who missed points on the first 2 problems, if I ask those again on the final, I believe in my heart you will get those right, right? Not those specific numbers, but the general idea. Parametric equations. You guys killed this question like much, much better than on the quiz. Much, much improved. There's still people with a couple of, still a few of you who are working on it and didn't quite get there yet. Hopefully for the final, you'll work that out. Again, it's the same trick I use every time. The point plus t times the difference of the points. Notice I didn't say colliding tangent. I mean, if you'd given me the parameterization of the colliding tangent line correctly, I would have given you credit for that too. If you also used, well, I don't know if that's possible. But this one here, it wasn't the same as the quiz, it's a little bit different. But again, the key here is that cos squared minus sin squared is 1. Cos squared, of course, is x minus 2. Sin squared is y over 2. So that equal to 1 is the, I give a lot of people full credit for this. You know, of course, it's nice to solve for y. Y equals 2x minus 6. Cartesian equation. Cartesian equations just have x and y. Your book calls them rectangular equations, but only x and y. If you have a theta in your answer, it's not in Cartesian form. All right. This one here, a lot of you got it right, so I was pleased. Many of you, I use color coding to kind of tell you what I did better here. So it's one of these guys. The arc length, and a lot of you got the arc length correct. I chose to quadruple the integral from 0 to pi over 2 of the square root of dx. Well, you know, the ds, of course, is r dot, ds, the polar arc length works out to r squared plus the square root of dr d theta squared d theta. Like this is the ds in polar coordinates. We worked that out in class. So if you didn't derive that here, I wouldn't be upset. One of you tried to just parameterize in terms of polar coordinates, and you did it correctly, so I give you full credit, even though your answer looks way, way more complicated. I don't know who that was. I should remember. Someone had like a much, much longer answer, but I looked at it, I was like, oh, this is right. It's just dx dt squared plus dy dt squared using t as theta. And it's, but this is what I intended. Equation, you guys got a wording. I say find the equation of any horizontal tangent. That means you have to find the equation. The equation, y equals 1 or y equals minus 1. Notice that we're going from minus pi to pi, which means you got either plus or minus pi over 2 as solutions to cosine t, right? So a lot of you got like half of the solutions, not the other half. You need to, think through the algebra. Likewise down here, dx dt equals to 0. Well, that's e to the t minus 1 because there's a t here. And so e to the t equal to 1 when t equals 0. T equals 0 is not the vertical tangent. What happens when you put t equal to 0 back into these equations is the vertical tangent. In particular, x equals 1 at 1, 0. Yeah, words, yes.
Isn't minus pi equal to 0 or 2 pi?
I'm sorry?
On a graph, if you did minus pi, wouldn't that be opposite where pi is? So that would be
What are you asking me about?
the balance.
This is not the polar angle, though. This is a parameter, t. Oh, I see what you're thinking, but no, that's not the polar angles. That's why what you're saying is not. Yeah. A lot of you got part C right. Woohoo! Move on here. We're out of time, so I'll try to go on. Surface area of a sphere. I wanted to see if you could do it. I think the answer was no. But I do think this is a reasonable question. I might have just as well have been calculate the circumference of a circle. Would that have turned out much different than this? I don't know. But you do 2 pi y ds. I would suggest using theta as the parameter. So basically I'm thinking theta equals to t. The speed is x dot squared plus y dot squared is r squared here. So we get ds is r d theta. Of course, geometrically, you could just see that from this picture. ds is r d theta. That's the usual interplay between arc length and angle. And so anyway, 4 pi r squared. This one here was a disaster. This was just an absolute disaster. I don't even know where to start about this one. But it is a hyperbola, folks. Like, you guys, so many of you had this algebra right up to a sign. Like, a lot of you, and me included, when I first did this, I got a plus over here, which is wrong. It works out to minus. And when you distribute that through, you get y plus 1 squared minus x plus 1 squared. If you've got a difference of squares, that's not a circle. That's a hyperbola, okay? Hyperbola. And so you got to be aware of that. And also, I think a lot of you did not really read this problem thoroughly because I didn't get parameterizations from a lot of you. I don't believe it's the case that most of you who didn't write an answer down don't know how to do it. I think a lot of you just didn't notice that it was also asked here. Am I right? I mean, now if you just didn't know, I understand that too. I mean, there's a lot to remember and learn and stuff here, but there's the parameterization. This was a bonus question. You have a homework problem that's related to this, I know, because one of you asked me about it. This is Josh's fault, right? Remember the rotation problem you brought to me?
This is extra embarrassing because I didn't get it entirely right.
Yeah, I don't think anyone got this right. Did one person get this right? I want to say one person got this right. I can't remember who it was, though. Who? Maybe Jane? Was it Jane? Well, let's not look. Anyway, so the point is, you find the equation and then just shift theta by pi over 4. That's how to rotate a graph. But I did not emphasize this. There was a homework problem that was about this. That's the reason I did it at all. But there were 140. There were 140 points. I personally view those as 5 of the bonus points. This is actually a really weird parameterization of a line. And so you get slope as 1, but there's a reason for that. If you find the Cartesian equation of this, it's actually y equals x minus 7. So of course dy squared dx squared is 0, but here's the calculation. A lot of you got that. Woohoo. And actually a lot of you got part C too. I was very, very happy to see that. I was not expecting that actually. And a surprising number of you found this point. This is a very strange world I'm living in where you can find this point, but can't parameterize a hyperbola. This is weird to me. No, that's not the thing. The not being able to find the polar coordinates at the start, but being able to do this problem. That's messed up. It's just messed up. This ain't right. This ain't right. Now, listen guys, a lot of you put pi over 3 here. The slope is pi over 3. That's not right. The tangent of pi over 3 would be the slope. Tangent theta is y over x. Or it's dy dx in this context here. Anyway, I'll let you look at that. Finally, the last problem, 13. I gave you 10 points if you at least drew this correctly, approximately. And I did 10 points for actually calculating the area. I think no one calculated the area correctly, as far as I can cipher now. There's, of course, the possibility that I'm wrong and that you're right. And if you become convinced that that's the case, you can argue with me tomorrow. And I'm happy to listen to you. But the way I see it, there are 3 parts to this. There's the top piece and the 2 bottom pieces. And the top piece, the outer radius is 1. The bottom pieces, the outer radius is the weird one, the 1 plus sine theta or whatever. And so I got to divide, the outer radius is different in the different parts. The inner radius is always 0. So I calculated it as 3 separate integrals in principle. Did I forget to double that? Oh no, I noticed that the area of 1 and 2 and 3 I can get from going from pi to 2 pi. So that's what I did. And I got 5 pi over 4 minus 2. So, but many of you were in the hunt for this, so you didn't lose a lot of points on this problem. Compared to the parameterization problem, the class is much closer to the truth here. So I'd say the parameterization of circles and hyperbolas could use some work for most of you. But anyway, I shut up. I'll see you guys tomorrow.